Hello everyone, we are back again with the parallelogram this time, and it's on special request. So to understand the parallelogram, to start the questions of parallelogram, we have to understand the properties of parallelogram. So what do you mean by properties? How does the sides or angles of any polygon behave? That means properties. So let's talk about it. All we know, these are sides, these are angles. So are the opposite sides of parallelogram equal? So they are talking about this thing. Yes, they are equal. This thing, yes, they are equal. So it's a yes. Are the opposite angles of parallelogram are equal? So yes, this angle would be equal to this one, opposite one. And opposite angle means this one would be equal to this thing. And if there is any background noise, please pardon me this time. Okay. So, do the diagonals bisect each other? The diagonals means these are the diagonals, and bisecting means whatever is their length. Means if the full length of BD diagonal is 10, so this part and this part would be 5, 5. Yes. And the full length of AE is 15, this part and this part would be 7.5, 7.5. So yes, they bisect each other. They are bisectors of each other. So yes. Are the diagonals equal in length? No. As we can see, one would be longer, one would be shorter. So no. Do the diagonals bisect the angles they pass? Means AE, would AE bisect my E angle? Means would this and this be equal? No. That's a no. Because no, it won't. We're gonna understand this whole thing in a 3D format as well. Let's just discuss right now. Do the diagonals meet at right angle? As we can see, no, they are not meeting at a right angle. This is some other angle. This angle would be same as that because vertically opposite. This and this would be equal, but no, they are not meeting at right angle. So it's a no. So there is a no for that. That is it for parallelogram over discussion. Let's move on to our 3D form. Okay, so this is a parallelogram. We can change its direction, its length, its height, but all the properties it is following would be same because it is still a parallelogram. So you can talk about this one, you can talk about this one. This is also parallelogram, anything. Okay, so I like this better, so let's go for it. Are the opposite sides equal? Let's check. Yes, they are. You can see 6, 6, 6.42, 6.42. Yes, they are. Correct. That's what I said. Are the opposite angles equal? Sorry about the honking. Are the opposite angles equal? Let's check. They are. Red one and blue one. They are absolutely equal. The opposite ones only. Do the diagonals bisect? Yes, they are bisecting. The half of it is 2.81. Other is same. Yes, they are bisecting. Next, are the diagonals equal in length? Obviously, no, they are not because one diagonal would be longer than the other. So, do the diagonals bisect the angles they pass? No, because see, red angle is different, this angle is different. So, no, they are not bisecting the angles they pass through. Next one and the last, do the diagonals meet at right angles? No. That's what I said. No, they are not intersecting at right angle. Just about right, but it's not obviously. So yes, all three last properties are incorrect over here. So I hope you have understood this whole thing. This is the parallelogram. In quadrilateral is one of a quadrilateral. So here only let me tell you, the parallelogram can be converted in rectangle, little 90 degree, yes, rectangle or a square. So square and rectangle are special types of parallelogram. So you should know that. And that's it for this time. Bye bye. Take care. Do mention other topics you want to understand. So okay, bye bye.